In this video, we will be covering parts B and C of problem 12.6 on page 203 of your textbook. In part B, we're asked to estimate with 95% confidence the difference in mean distance driven by male and female drivers. And we'll be using this formula here, which is the equal variance confidence interval estimator formula. Now that is a big mouthful, and you can see here that it's got x bar sub 1 minus x bar sub 2 plus or minus t alpha by 2 times the square root of, and this whole thing is referred to as the pooled variance estimator. So it's the sub s p squared multiplied by the sum of 1 divided by n1 plus 1 divided by n2. Now, to make this easier to follow the calculation and actually perform the calculation, I'm going to break down this equation into its parts. So the first part will be the x bar sub 1 minus the x bar sub 2, and then we'll use the t for the alpha by 2, which is that the point 5 divided by 2, or the 0.025, and then we'll do the calculation for everything under this square root, and then we'll be able to use that to calculate the lower confidence level and the upper confidence level. So let's start with x bar 1 minus x bar 2. So we'll go equal, and we already did these calculations up in part A, so I'm just going to scroll up to show you that. And in this case, we have the x bar 1 right here in E12, and notice x bar 2 in E13. So we'll just use those both. I'm going to click enter, so it brings me back down here, and I shouldn't have done enter, I should have done equal, and then it's going to be E13, if you'll recall, and then hit enter. So that's going to give me the answer of 0.57. And now for the t for alpha by 2, we've got that number already here in cell E39. So again, you can look again on table 4 on page 311 of your book and see that. So I'm going to hit return, which gives me the 1.972, and then I want to do the square root calculation, which in this case is going to be equal to, and then SQRT for square root, open parenthesis, and in this case the S sub p squared has already been calculated right here in cell E30. So then click on that and multiply that by 1 divided by, and in this case it's going to be 100. We could go up and choose the n up here, so I guess we'll do that. N1 is right here, plus 1 divided by N2, and to close the parentheses on that, you can see that the green parentheses right here and here are one set, and I'll put another parenthesis to give us black to close that, and click the check to enter, and that gives us the calculation of 0.4075, and really we should round this to 26. So I'm just going to click down there, and we've got that part of the calculation done. So with that, we have all the numbers that make up this larger equal variance confidence interval estimator formula, And now we want to actually do the lower confidence level and the upper confidence level. So first we'll start with the lower, and it's going to be the x bar, and in this case then it's going to be minus the t multiplied by the square root. And just to make that a little easier to read, I'll put it in parentheses. Order of operations would suggest it'll do the multiplication before it does the subtraction anyway, but I think this makes it a little clearer. So I'll hit enter, and that gives us the minus 0.23. And now let's do the upper confidence level, which is again that x bar calculation plus, and it's going to be the t times that square root, and hit enter, and there we have 1.378. So there we've correctly calculated the lower confidence level and the upper confidence level. I'm going to pause for just a moment, and then I'll come back and solve part C. So in part C, we're asked to check to ensure that the required condition or conditions of the techniques used in part A and B is satisfied. And both with the equal variances and the unequal variances techniques require that the populations be normally distributed in order for the required condition or conditions to be satisfied. And the way that we can check to see whether that requirement is satisfied is by drawing the histograms of the data. So in this case, remember we're comparing males against females, the males being indicated by number 1 in column B, and females by the number 2. In my case, I've already sorted. I'm re-recording this video because of a problem, so I'm not sure. You may have to sort both of those columns to make sure they're in order. And in this case, though, what I'm going to do is go up to the Data tab, and then I'm going to select that Data Analysis Tools. And once that dialog box is up, I'm going to select Histogram. Click OK. In this case, I'm just going to deselect everything in there and go ahead and choose the input range. Now in this case, the input range is actually going to be in column A. I'm going to slide up here, and it's going to be from A2, and I'll go down as far as the number ones continue in column B. So we see that it goes right down here to A101. I can click here to go back into that dialog box range. I didn't include the labels because I won't be able to include the labels with 2, so we're fine there. The output range, I'm going to select a range here, so I'm going to click here and now scroll up, and I am going to place it right here in cell D53. And I also want to make sure that I've selected chart output by making sure that there's a check showing in that checkbox. And once I've completed that, I can click OK. And you see that we've got the bin set up right here in D53, and I believe I've got a histogram showing up somewhere up here. Here it is. So I click on that, and now I should be able to drag this down to place it in the proper position, and put it right here. I'm going to adjust this slightly, so I'm going to resize it, make it a little taller. And I'm going to move this around just a little bit so we can see all of it. And the other thing, if I right click on some of the series of data, I'm going to choose Format Data Series, and right here the gap width between how it's charted in the histogram, I'm going to move that from 150 down to 0. And then close. And you can see right there I've got a nice histogram for the males, and it basically has the shape of a normal distribution. I mean, it's not perfect, but clearly it's got one peak point and roughly a bell-shaped curve. So we're fine with that. So what I'm going to do now is go down here to cell D69, and now I'm going to go back and choose Data Analysis again, Histogram, click OK, and in this case I'm going to go up here, and instead of from A2, I'm going to choose A102, and then instead of 101 it's going to be 201, and I will show you that right here. So if I go down, you can see it starts in A102 and it goes all the way down to A201. That is the last cell. And I'm going to get rid of the output range. Click here and then scroll back up and select this cell D69. Again, I've still got chart output, which is what I want selected, and I'll click OK. Gave me the new bin with the frequencies, and now I just need to scroll up and find where it placed that histogram, which is up here, and I'm going to click and drag it down. And I will make it a little smaller so it fits better. Right click again, Format Data Series, go from 150 gap, percent gap to 0%. And again, it's not a perfect normal distribution, but it's close enough to indicate that the conditions are satisfied, that we have a normally distributed set of data. So that's fine. We've now solved that, and I can just put this little note: both histograms are bell-shaped. So we should be good with that. And that's it for this video.